Hello and welcome back to 30 Days of Python. Today is day 10 of the Python challenge and we are looking at loops. So if you think about it, without loops, if you wanted to process 1,000 items, you need to write the same code 1,000 times. Like printing hello world, for example. You have to print that 1,000 times. So that will be 1,000 lines of code printing hello world over and over again. But in a loop, you need to print out maybe a few lines of code to have a repetitive output. So this is obviously a game changer in terms of programming. So let's get on with it. Let's begin with a for loop, which is perfect for when you know exactly what you want to iterate over, like items in a list, characters in a string, or numbers in a range. So in this example here, you can see that you are looping through a list. The list is fruits and we use a for loop to do so. In the for loop, you're going to specify the variable that you're looking at, which in this case is fruit, and use the in operator to specify what you're looking at. So in this case, we're looking at the list fruits, and you print, and for each fruit in the list of fruit, you're printing out fruit. And in this example, again, you're just printing out the sentence of whichever fruit it is delicious. And outside of that loop, you are now printing the loop as finished. With a for loop, it doesn't iterate repetitively, but it will iterate as long as the list goes. So however long the length of the list is, it will iterate over each fruit or item in that list. So looping through a string, the word Python consists of 6 letters. So for each letter in the word Python, we can iterate through each one of them. And if you loop through a tuple, in this case colors, we can loop through the colors and it will print each of them out. So you can see a pattern here, right? For item in a collection, for each item in the collection, do something. The intended code runs once for each item, and the variable like fruit and letters or the colors automatically takes the value of the current item. So what if you want to loop a specific number of times? That's where the range function comes in. It generates sequences of numbers. So when we look at the basic form of a range, we specify it with the letter I. For example, for I in range 5 and then print out I, you can clearly see you will end up with 0, 1, 2, 3, 4, because iterations, as you know, starts with 0 rather than 1. We count from 0 in computer science. When we're using the start and stop range, we're looking at the start of a range and end of a range. So in this case, when you start a range in the range function, we specify the start, as we say here, with index 2, and we want to end before index 6. So the way that will work, keep in mind, is that it will stop -1 at that endpoint. So in this case, when you print I, you'll start at 2 or index 2, which will be the value 2, and continue on to 5, which in this case is the value, which in this case is 5. With a range step, we add a third value inside the parentheses of the range function. We have start, a stop, and a stepping point. So in this case, if we're starting at 0 and ending at 10, but we're stepping for every 2 counts, therefore when we print I, we end up counting in 2s. Counting down sequence or loop should work with the opposite directions, as the -1 or negative values go in the opposite directions, as we've seen in week 1. For a more practical application, we can see that we have a multiplications table. So a variable of integer 3 is assigned to number, and for each I in the range, we are specifying from 1 and stopping at 6, which means it should count from 1 through till 5. And when we print out, we are printing out the number times I. So 3 times whatever the value of I is up until 6, up until the space of 6, in the index of 6, which is 5. So the endpoint should be 3 times 5, which is 15. So just remember that range stop goes from 0 to stop minus 1, and the range start stop goes from start to stop minus 1. The range function is incredibly versatile for numerical functions. We are now moving on to the while loop. When you don't know how many times you need to loop through a range or an item list. So you use this when you don't know how many times you need to loop in advance, right? You just want to keep going while a condition is true. This is usually in use case more used when you're testing out a boolean. So if you look at the examples provided, a basic loop will be that a count equals 1, while the count is less or equal to 5, print out the count, and then count plus 1 will be a very important step so that the count can actually go up. So it will be 1, we'll print out the count 1, and then plus 1 will keep on adding up. A user input example will be a blank string variable such as password, while password does not equal, the exclamation mark means does not equal secret password input your password, and then it will, once it's looped out, once you've inputted your password, it will print access granted. If you print out secret, you will end up looping through the password again and again, and the sequence won't end. A practical example will be when you have a import random. Don't worry about that as of right now, but if you're doing a number guessing game, the random is a function in the library of Python that will help you randomly generate a number, and in this case the variable target is assigned random integer between the variables, between the integers 1 and 10, and guess is assigned 0. So while guess does not equal target or is not assigned to target, guess the integer input from the user. If guess is less than the target value, so between the ranges 1 and 10, print to low. Else if guess is greater, you'll print to high. But if the person does get it, it needs to break out of the loop. So if guess does not equal target proves to be false, you'll break out of the loop and you'll print you got it. So critical point here is that always make sure your while loop has a way to end. If the condition never becomes false, you get an infinite loop that will crash your program. That is important. So there will be times where it will check for a boolean, but if the boolean, and you know that it will not ever pull out to be false, you can use another function called break, because if you need to loop through a list, if a boolean is true or if the boolean is false, and you need to continuously loop through a list or a document to find something, regardless of any intervention, at some point you need to break through that loop. You can use a break function. Now let's look at loop control. Sometimes you need to control the loop. Python gives you 3 special statements for this. Like I said before, break, another is continue, and the other is pass. The most common one, break, is used to exit the loop entirely. In this case, the for loop, for number in range 1 to 10, if number equals 5, break. It will exit the loop immediately. If it doesn't, it will print the number. And then outside of that loop, you can see it says the loop is broken. For continue, it will skip to the next iteration. So for example, for a number in the range 1 to 10, if the number is modulo 2 that equals 0, continue. If not, you print that number, because it will only print the odd numbers. For pass, it's a do nothing or placeholder. For number in a range of 5, if number equals 2, pass. We'll add and then add the logic afterwards, right? Else you print the number. So let's look at a practical example of this. You have a list of names: Alice, Bob, Charlie, David, Eve, and you have the variable search name, which is Charlie. So you want to look for Charlie in the list of names. So for name in the list names, print checking the variable name. If name is equal to search name, so if the list has the name Charlie, which is our search name, then print the found them, and break. Else you let the loop run. In this case, else it's outside of the for loop, and as you see, the comment reads that this will run if the loop completes without the break. So it means it went through each name. There are 5 here. If it runs through each of the 5 names and Charlie is not in the list, it will just run through the list and it will print out name not found. So just think of it this way. A break is an emergency exit. A continue is for skipping one item, and a pass is for when you need syntactically something but logically nothing, if that makes sense. Now we're getting into the more advanced things with loops. These are called nested loops, putting a loop inside another loop. So it's incredible for multi-dimensional data. In this example, we can see a multiplication table for I in the range of 1 to 4 for the outer loop, and for I in the range 1 to 4 for the inner loop. So in this case, it's kind of the same like printing a 4x4 table. In the next example, you can see it processing 2D data, and you're creating a matrix. And you can see in that list or matrix, you can see 4 row in matrix, that's the outer loop, and 4 number in row. So there are 3 rows in the matrix because there are 3 lists, right? And there are 9 numbers or 3 numbers per row. So then you'll print out number and the end, and you can leave another blank print to print a new line for each row. So there's also pattern printing for I in range 5, that's the outer loop, and then for J in range I plus 1, you then print asterisk and end with blank, and then you print a new line after the row. So the inner loop completes all the iterations for each single iteration of the outer loop. It's a perfect for grids, tables, or any structured data. So going back to day 8, when we did dictionaries, we can also loop through dictionaries. So if we look here, we going back to the dictionary that we used in those previous examples of person, we have the labels name, age, city, and job, with the values of Alice, 25, New York, and developer. To loop through this, we say for each key in the dictionary person, we can print out the key. So we'll print out every key item there, so it'll be name, age, city, job. We can loop through the keys explicitly by specifying the dictionary .keys function and then print out each key. We can loop through the values by specifying the dictionary .values and printing out the values. We can also print out the keys and values in pairs by calling both key and value in the for loop. So for each key and value separated by comma, in the dictionary person dot items, and you can print out the keys and value line by line. A more realistic example will be word frequency, like we did before in finding how many words there are that are repetitive in the text. You can see in this text we have apple repeats once, and banana also repeats again, and apple repeats 3 times, and orange appears once. So words you can assign to text.split, and then you have a word count in an empty dictionary. So the first loop will be for word in words, then word count the list of word, assign that to word count.getWord, and then plus that by 1. So you're starting, and the starting point is at 0. So then the next for loop will be for word and count in the word count.items, and then each word that goes through will print out and the amount of times it appears. So apples appears 3 times and bananas appears twice, for example. So using the items function, it is usually the best approach because it gives you both the key and the value together in a clean, readable way. We can also go back to day 5 when we did lists. So obviously the traditional method will be the first block of code showcasing the traditional way to loop through a list. So squares will be an empty list, and for I in the range of 1 to 6, we can then, the function will then be squares.append I square root of the value of I, and then print out the squares. List comprehension will be the same result but in a single line. So I square root for I in the range of 1 to 6. With conditions, even squares, same thing in a straight line or single line of code. The square root of I for I in the range of 1 to 11 if the modular of I to 2 is 0. It will print even squares. For dictionary comprehension, you specifying the key value of I, square root of I, and in the range of 1 to 6, and it will print out squares dictionary, the dictionary comprehension of the square roots. And then the set comprehension, you taking the length of a word, and then for each word in the list, you printing out the unique length of the word. So there will be 3 words essentially, since we know that sets don't take duplicates, so it will be apple, banana, orange. So it'll be 3 unique words. So comprehensions are more Pythonic and often faster than traditional methods. So you use them when you're building new lists or dictionaries or sets. Now let's look at the common error points that we all go through, as we usually do in our roundup of the series. So the first one are infinite while loops. We tend to overcompensate for the loops when we don't need them. So the first one, infinite while loops, the count is 0 and the while count is less than 5. We print out count, but we didn't increment the loop. So you'll continuously loop and loop and loop, and it will just go on forever until you kill it. The next one is to modify the list while iterating. So this is where we say you shouldn't iterate through a list when you are intending to modify it later on. So a for loop runs as for fruit in fruits. If fruit equals banana, remove fruit. That actually will destroy the list. That will give you errors. So once it is removed, it won't appear there anymore, and the function will just break. The next one, so instead of using that method, you can iterate over copy. So for fruit in fruits, and you specify it by using the colon inside the new list. So the open brackets and the colon inside will specify like to create a copy of that list, and you can loop through the list without any errors in your code. The last example of errors that we run into is using the range and length in the, or more specifically, just putting it in unnecessary positions. So the list of names, there are 3 of them. So for I in the range, and then you, for each range of the list, you check in the length of the names, which will just print out or loop through the length of Alice, and then also the length of the list, and then the length of Bob, and then the length of the list, and then the length of Charlie, and then the length of the list. It makes no sense to do that. So instead, you can go for I name in enumerate names, and then print out I and name. And there we have it. That is loops. You now have the power to process any amount of data efficiently, automate repetitive tasks, and write code that scales beautifully. If you found today's video very helpful for you, please consider subscribing and liking the video, and I will see you next time.